Hello, this is an introduction to scatterplots from section 2.4 of the textbook. Um, the whole idea here is we're looking for relationships between two variables when you have a quantitative explanatory variable and a quantitative response variable. Then you can show this relationship with a scatterplot. And here's what scatterplots is all about. Let's start with an example. So it says, example, highway signs. It says, a Pennsylvania research firm conducted a study in which 30 drivers ages 18 to 82 were sampled, and for each one, the maximum distance in feet at which he or she could read a newly designed sign was determined. The goal of the study was to determine the relationship between a driver's age and the maximum distance at which signs were legible, and then use the study's findings to improve safety for older drivers. All right, let's scroll down here. The explanatory variable is age, the response variable is distance. So here's some raw data. There's 30 individuals, but here's the first 4 drivers. So driver number 1 is 18 years old, and that person could see a sign that was 510 feet away. The next driver is 32 years old, and that driver could only see 410 feet away. Driver number 3 is 55 years old and could only see 420 feet away. And so, I mean, common sense tells you as you get older, your visibility should decrease because your eyes are getting worse. And so, is that indeed a fact? What does the data say about it? So, by scanning through the raw data, you can get an idea of a relationship between age and distance. But to get a better idea, let's go to a graph of this. So let's make a scatter plot. So scatter plots look like this. It's basically it's an x-axis and a y-axis. On the x-axis, we'll put age. Explanatory variable always goes on the horizontal. And then for the y-axis, we'll have distance. And then he just put a point. So the 18, 510, think of it as a coordinate. X equals 18, y equals 510. And you put the point on the graph. So for scaling your axes, use whatever makes sense. I suppose the youngest person is 18. Let's just go down to 15, and let's just go by 10. So 15, 25, 35, 45. Just have a uniform scale, 55, 65, 75, 85. The oldest person I think was 82, so we'll go up to 85. Okay, the distances. Well, it looks like 400s and 500s is common for the distances. Let's start at say 300. So 300, and let's increase our y coordinates by 50s. So 350, 400, 450, 500, 550. Maybe there's someone who can see 600, so I'll write 600 here. Okay, and then you just plot your points. And so the first driver, 18 years old, 510 feet. So find 18, roughly about there. 510 is a little bit higher than 500. So you just like in graphing in algebra, you just put a point to represent a person who's 18 years old can see 510 feet. Okay, next driver, 32, 410. So X 32, Y is 410, so right about there. Next driver, 55, 420. So 55, 420, right there. And our fourth driver, age 23, 510. So 23 years old, 510, right about there. So that person can see as far as the 18-year-old person can. And that's the first 4 data points. Now, if you were to continue this for all 30 drivers, you would get 30 dots. And so let's just make up some more dots here. So it would look something like this. And you would start to see a general trend that as we saw, as a person gets older, in general, the person's distance that the person can see starts to decrease. So that is called a scatter plot. And it's a really nice way to visually show the relationship between two quantitative variables. Now, in the reading, you'll learn all sorts of details about how to describe them, how to analyze them, how to come up with equations for the line, and so on. But that's just a quick introduction to what a scatter plot is.